Something that comes up almost every year in your exam is the hypothesis test, but that hypothesis test starts with the margin of error. Okay, let's see. A random sample of 355 people was picked from everyone who took part in a park run in 2023 in Galway. So there was people that were running in Galway, right? So there was loads of people, but they pick a sample. Out of all these people, they pick a sample of 355 people out of everybody that in 2023 partake in the run. Show that for this sample, so for 355 people, the margin of error for a population proportion is 5.3%, correct to one decimal place. So there it is. Once you see that word, margin of error, on your paper too, okay? It's a stats question. Once you see that, this is the formula how we calculate that margin of error. 1 divided by square root of n, where n means number in sample. Now, the problem with that, it's not in your table. You have to remember that's how it is calculated. So in this case, it's 1 divided square root a number of people in the sample, in this case 355, and we put that in the calculator, we press equal, that changes to a decimal, and then we change that decimal to percentage, we move that to decimal point 2 places, so we multiply by 100, and indeed is 5.3. But that's what I'm saying. Once you see margin of error, that is the formula, and you have to remember it because it's not in your table. Next part. 96 of the 355 runners finished the run in under 25 minutes. So we understand in that sample of 355 people, there is a group here, 96 of them, and these people run less than 55 minutes. The rest of the people, more than 25 minutes. We get the idea. Work out the percentage of runners in this sample who finished the park run in under 25 minutes. So when they are saying work out, calculate, find percentage, we think about fraction. Remember, at the bottom of the fraction, the whole cake, on top of the fraction, my slice of the cake. In the context of this question, the whole cake is the sample, and then my slice is people that did 25 minutes, less than 25 minutes run. Okay, so the number of people is 96, and then all of the people in the sample, 355. And when we put that in the calculator, we press equal, we'll get decimal, and decimal we change to percentage, and to the nearest percent, we get 27%. And again, this question follow that, usually that pattern, margin of error. Then here, what we actually found, it's something that's called, it's P with a dash, and it's called population proportion. That's basically a portion of population. That's all what it means. Okay. A running club commentator said that Galway Park run times have changed since 2019. In 2019, it was reported that 24% of all runners, not a sample, all runners, finished the park run in under 25 minutes. So again, let's understand, there is 2019, there is Galway race, and we have all these people, all, not some, and in that all people, there is a part that is 24%, and they run fast, less than 25 minutes. Okay, use your answer to part B1 and B2 to test the claim that the percentage of runners who finish the park run in under 25, a lot of words, isn't it? So what are we doing? We're using the answers before to do what? To test. What are we testing? A claim. What kind of claim? That the percentage of runners who finish the park, who finish the park run in under 25 minutes has changed. We are testing again what? Let's pick the main thing. Percentage has changed. That's what we are saying, that those fast people, they change. Because again, in 2023, what happened? There was another Galway race. There was all these people. However, here, from all these people, they pick a sample of 355, and in the sample here, all people, here sample, we got a different outcome. And then they are saying that that test we are doing is at 5 level of significance, a 5% level of significance. That is another name or a fuller name for hypothesis test. That's basically what it is, that 5% level of significance. We are talking about hypothesis test. We have to show calculation, state conclusion, and give a reason for our conclusion. Okay, so how do we run the hypothesis test? So here, and I know here they didn't mention, usually in your exam they will mention a hypothesis test. Here they didn't mention, they just call that 5% level of significance. So we need to know that that phrase means hypothesis test. Okay, so first thing we have to understand what happened here, that there was a hypothesis stated. The null hypothesis and alternative hypothesis. Null hypothesis is saying, doesn't matter anything, nothing changed. In this case, we are talking about the percentage. So the null hypothesis will state that the percentage has not changed. We know that this is percentage of the runners who finish the park run in under 25 minutes. The alternative will always set the opposite statement. So therefore, percentage has changed. And that's basically what it is. Null one, nothing changed. Alternative is saying things changed. Okay, so how do we work our numbers here? What do we do? So for the calculation, we are going to calculate something that is called 95% confidence interval. How do we calculate that? Now again, that formula is not in your table. We take population proportion with plus and minus, so we run two versions because we are creating interval, margin of error. So that's what it is. So that will give me two values. On one side, I will take my population proportion minus margin of error, and on the other side, I'm going to take population proportion plus margin of error. So basically, my population proportion stands in the middle, plus margin of error minus margin of error. So again, what is that population proportion? In our case, that was 96 over 355. Now, I will advise you here is better not to use percentages because then you have to be more careful with your calculation. It's easier to use the original fraction. So this side, from that 96,355, we will take away 1 over 355, and here 96,355 plus our margin of error. So when we put that in the calculator and press equal, we're going to get here 21.7%. And then when we take that and hit equal, we're going to get 32.3%. So that's our numbers. Now we do the test. What are we testing? Population, because this is sample. That's where we got those numbers. So what was the population percentage? Let's see. There it is, 24. So where is 24? Between 21, exactly. It's somewhere in between. The 24% is between those two values. Okay, so now we are writing the reason. So we are saying this is a calculation. As 24% is within confidence, we should say 95%, to be precise, 95% confidence interval now we have to refer to our hypothesis because it's inside the interval. The null hypothesis of no change stand, yeah? So we are saying there was no change in percentage of people who ran, and what was it? The park run, isn't it? Who ran in less than 25 minutes the park run. Basically, what we are saying here, the null hypothesis stand. We are not rejecting it. That's what it means. So the conclusion, we are saying that therefore there was no change in performance, isn't it? So we are saying therefore, forgive my writing, there was no change. In performance. So that's what I'm saying. When you are doing this question, the structure is always very similar. You can see it always start with the margin of error. Then we do population proportion. And then we are running that test. We are creating the interval and we are testing. Always remember, here is the sample. We are testing the population. Is it inside the interval or if it is outside? If it is inside, that null hypothesis stand, nothing changed. If it is outside of the interval, doesn't matter which side, then we are saying no, things have changed. That's basically what is the outcome. We only have to refer to the context of the question. So like here, we are referring to the, where is it? Percentage of runners who finish the park run in under 25 minutes. That's basically what we are referring to.